Hello, welcome back to the channel. In today's video, we'll be discussing about graphs. Yes, graphs are data structures in JavaScript. And in this video, we'll be discussing how you can implement graph data structure using JavaScript. And without further ado, let's dive in. So, what is a graph? Basically, graph data structures are non-linear data structures that allows you to connect nodes to each other. So basically, a graph data structure, like I mentioned, it is non-linear, and it has something called a node and it has something called an edge. And nodes are connected to each other via edges. And you must be thinking, how does this relate to a real life? And I think practically everything in our day-to-day society is connected. Anything that has some form of connection or some form of network is basically a graph. From your road network to basically your social media networks. All of this are represented in graphs. So for example, in Facebook, you have friends, and a friend is connected to another friend, and it keeps going down the line. Basically, Facebook uses a graph data structure to know that you as a person is connected to multiple friends, and multiple friends are connected back to you, and same applies to things like Google Maps. You have your road network. So road A can lead you to road B can lead you to road D, and road D can lead you back to road A. This is basically a network, and they are connected to each other. So this is what a graph is. And I think it's best I represent a graph in the diagram. So basically, a graph looks something like this. So as you can see, you have your nodes. These are the nodes. The nodes are circled that are circles, while the edges are the lines. The lines represent the edges, while the circles represent the nodes. So you have your node 0. Node 0 is connected to node 1 and node 2. Node 1 is connected to node 2 and node 3. Node 3 is connected to node 1 and node 4. Node 4 is connected to node 3 and node 2. And same applies to 5 and 6. Basically, this is how a graph is represented. Now, graphs have different types and different kinds. So you have the directed graphs and you have the undirected graphs. So directed graphs are usually the ones that have arrows pointing to each other. So if we are to use an arrow instead, if we were to use arrow to this, you could see that, okay, this connects to this. And, same applies to this. If you were to use an arrow over here, you should have seen that, this connects to this as well. So arrows or directed graphs can be unidirectional, it can be bidirectional. But usually it's unidirectional. And you have also the cyclic and acyclic graphs. So cyclic graphs are basically graphs like something like this, 1, 2, 0, 1, and 2. Cyclic graphs kind of like forms more or less like a circle. It's a graph that kind of like forms a round circle. Meanwhile, acyclic graphs are the ones that are the complete opposite of the circular graphs. Acyclic graphs are something like this. So basically, you know that this connects to this and this connects to this, but this doesn't have any ending. So like, it doesn't have a circle-like structure. It doesn't have a round, or it doesn't have like a round connection, something like that. So that is for acyclic. And you have weighted and unweighted graphs as well. So weighted graphs are graphs that have different weights. So if this were to be a weighted graph, you would have something like 4 here and something like 5 here and something like 12 here. So something like this is used to identify a weighted graph. And unweighted graph is the complete opposite. Unweighted graph is when you don't have any of the numbers on the edges. That is unweighted graph. And you can be wondering, how does this apply to real life? How and where could we apply, the directed graph and undirected graph, weighted and unweighted graph? And for unweighted and weighted graphs, weighted graph are super valuable when you are building things like maps. Let's say you are building a Google map equivalent and you want to show a shortest path from point A to point B. You can do that easily using weighted graphs because you can see that this particular path is shorter than this particular path, something like that. So for directed and undirected graph, you can use the analogy of Facebook. So for example, Facebook, your friend circle of Facebook can be described as an undirected graph because you are connected to your friends and your friends can be connected to you and both can see each other. Meanwhile, the directed graph usually can be described using Twitter, for example. Twitter, you can only connect to a friend, and even though you're connected to a particular friend, their friends cannot see your friends, something like that. So like it's basically bi-directional. Twitter is unidirectional. Why Facebook can be or bi-directional, something like that. So so these are the different kind of graphs that you have, and there are different ways we represent data in graphs. So, I mean, you agree with me that it would be very hard for you to draw out something like this in code. I mean, this as it is not how it is represented in code. Apparently, this is represented either an array or a linked list or an object. And for graph, it's basically implemented using either a linked list or a tree. So you can implement a graph using a linked list or a tree. And before you dive into the implementation, it's important to understand how you can arrange different data using JavaScript. So the graph data can be arranged in multiple ways. So you can arrange a graph data in something called an edge list. An edge list. You can also represent graph data in an adjacent list or adjacent list, anyone. And you can also represent a graph data in an adjacent matrix. And so these are like the three different ways you can present the graph data. And for edge lists are usually something like this. So you have an array, and an array contains multiple arrays. So to represent the connections of 0, all you need to do is you first of all write down the node, and then you write the connections. So it should be 0, 1, 2, and for 1 should be 1, 0, 2, and so on, so on. And for adjacency lists are a bit different in the sense that instead of you denoting the nodes, instead of you writing the nodes and the connections and the edges, all you need to do is just use the index. So since we're using an array here, if you want to represent an adjacency list, all you need to do is, since we are doing for 0, the node 0, we identify node 0 as index 0. So this is the first index. Yes, so this is basically the first index, which is 0, and 0 has connections 1 and 2. So write 1, write 2. And second index is 1. So 1 has connections 2 and 0, so 0 and 2. 2, which is the third index. So index 2 has connections of 1 and 0. So write 0 and 1. And same applies to 3 and 4 and 5. And for adjacency matrix, it's a whole lot different. So for adjacency matrix, you represent data in zeros and ones. So basically, for adjacent matrix, you have something like this, where the first index, which is 0, first index, which is 0, is connected to 1 and 2. So because you know that the index of an array starts from 0, you check for 0. So 0 index at 0th index, it is connected. So you use 1. At 1 index, you use 0. At 2, you use 1. So the indexes are 1, 0, 1. And the indexes are 0, 1, 1. Because we are checking for 0. So 0, 1, 1. And for 1, it is 0, 2, right? Yes, for 1, it is 0, 2. So 0, which is 1, 1, which is 0, and 2, which is 1. And keep doing that until you get to the last node. So for the sake of this tutorial, we'll go with the adjacency list because it's really easier to represent. And I think it's time for us to implement a graph using JavaScript. So to implement a graph using JavaScript, we use trees. And to build a tree, we use a class. So we do class graph. Then we'll create our constructor function, our constructor method. And for our constructor, we need to have the adjacency list, adjacent list, adjacent list. Need to have the adjacency list. Then you have to have the number of nodes. We work up adjacency list and the number of nodes. And we need to create two important methods for our graph. And just like every other data structure, we need to increase an insertion or add node method, and then we need to create a add edges method as well. So let's create our first. Let's call it add node instead of using a vertex. And by the way, nodes are synonymous to vertex, so you can either call it a node or a vertex. So add node and add edges. So let's attempt the first one, which is the add node. So to add a node, you have a value here. Do we need this value? Yeah. Or node. Let's use the node here. So to add node, you have your node parameter, and all you need to do is you need to just call this dot adjacency list, and then you create a key. That's you passing the parameter into the object to create a key, and you pass in an array as the value. And once you do that, you increment the nodes by 1. So easy. And for edges, you have two parameters for edges. So you have something like node 1, you have node 2, and node 1 and 2 are different nodes that needs an edge. So you need to connect node 1 and node 2 using an edge. And to do that, all you need to do is you need to call this dot adjacent this dot adjacency list 1. Then once you get the value, you just push to that array. You push node 2 to that array, and you should do the same for node 2 as well. Node 2 and 1. Perfect. So this is basically our graph. And let's try and use this graph. Let's try and represent this graph that we have here as code. And to do that, first and foremost, we need to create a new instance. Let's call it test graph. And you have your new graph. Then once you do that, first of all, you need to add your node. So add your node. For the first node, we'll add 0. Okay, let's do for nodes 0, 1, 2, 3, and 4. So have 0. Zero, 1, 2, 3, and 4. I think we need to return this. So we've added our rows. Let's add the vertex. Let's add the edges. So 0 is connected to 1 and 2. So we do 0 and 1, 0 and 2, and then we do 0, 1, and 2, and we do 2. Okay. Okay, then if we do 0, we do 1 and 2, then 3 and 4, right? So we'll call the add address. Zero, 1, 0, 1, 0, 2. So we'll do for 0, 1, 2, and 1, 2, 0, 1. Okay. We'll do for 1 and then we'll do for 2. So 0, 1, 0, 2, then 1, 2, 1, 0, then 1, 3, 1, 2, 0, 1, 0. One, 2, 1, 3. So 1, 2, 1. So the reason why, if you notice very well, what we did here is we connected 1 to 2 and 3. We didn't bother connecting 0 again because already 0 has been connected to 1 and we've represented that in the array. So if you noticed when we are implementing when we are adding the edges, we do it such a way that node 1 has to connect to 2, node 2 has to connect to node 1. So what it means is that if we show a connection for this node and we want to do for this other node, we don't have to pass in this particular node because already it is stored in the adjacency lists. So I think that's that. Let's run. Awesome. It's run. And as you can see, our number of nodes is 5, which is 1, 2, 3, 4, 5. And let's view the connections. So we have our adjacency lists, and then we have 0 connected to 1 and 2. So 0 is connected to 1 and 2, which is perfect. And 1 is connected to 0, 2, and 3. 1 is connected to 0, 2, and 3, which is perfect. 2 is connected to 0 and 1. 2 is connected to 0 and 1, perfect. 3 is connected to 1. Yeah, it's connected to 1. We didn't represent 4. We didn't add vertices for 4. We didn't add vertices for 4, so it makes sense for it not to show any connection. So that makes a lot of sense. So yeah, that's about our graphs. This is basically how you create a graph data structure using Javascript. And yeah, thank you so much for watching this video. I hope you learned at least how to implement a graph data structure in JavaScript. And I hope you learned the different types of graphs that exist. And I also hope that you learned the different terminologies that exist in graphs, things like load and edges. And with that, thank you so much for watching, and see you in the next one.